Welcome to my YouTube channel. Dhanesh here. See, this is the third video on neural network. See, we already covered the architecture, the mathematical model for the neural network. All these things we covered. See, we understood artificial neural network is a computing system inspired by biological neural network and human brain. And the simplest architecture, see, I have shown in the previous videos, this is the architecture of the artificial neural network. It's having input layer, hidden layers. Hidden layer can be any number of, this is the simplest architecture I have given here. So hidden layers can be any number. Here I have shown two hidden layers. Blue and green nodes represents the hidden layers and the output layer. In the hidden layers, the computation or the calculation happens in the hidden layers. See, all these things we have covered in the previous videos, and I told as part of the artificial neural network we would be covering model architecture. It's already done in the previous video. Mathematical a representation of the artificial neural network, it's covered. So in this video I am going to cover about the activation function and the bias node. See, these two sections will be covering as part of this video. Then the cos function, forward propagation algorithm and backward propagation algorithm will be covering in the coming videos. So in this video I am going to cover about the activation function and bias node. So coming back to the activation function, see, in the last video when we discussed about the mathematical model for the neural networks, I discussed about activation functions. In neural networks, the activation function defines if given node should be activated or not based on the weighted sum. See, when you take a node, see, in this architecture, the circles represents the nodes, the blue circles, the green circle. For example, if you consider the first blue circle, that should be activated or not. It is based on the weighted sum. See, the weights, the black arrows here represents the weight of the neural network. We already discussed. See how many weights are coming towards this first blue node. There are 3 weights, right? See, from the 3 red nodes input layer, see, 3 weights are coming towards this first blue node. So the sum of all these weights determines whether that first blue node should be activated or not. So this is the activation function. In a neural network, the activation function defines whether a given node should be activated or not based on the weighted sum. Sorry. See, we use different types of activation functions in neural networks. The different types of activation functions we use in neural network are, I will give you an idea on that. It is just one second. So the different types of activation functions we use in the neural network are, first one, I can tell you the linear function. The first one is the one second. It is the linear function. First one, it should be the linear function, or you will call it as a ReLU or rectified linear function, or ReLU, rectified linear unit. This is the first one. We will go in detail about all these activation functions. Second one, it is the sigmoid function. Sigmoid function. This is the second one. Third one is the, so you have the linear ReLU. Then the third one you can have the step function. The third one is the step function you use. So these are all the activation functions you usually use. Fourth one is the hyperbolic tan. Hyperbolic tan, or we usually write it as tan hx, tan h, hyperbolic tan. So these are all the activations, commonly used activation functions, but most commonly used activation function in neural networks, I can tell you, it is the sigmoid function. Sigmoid function is the most commonly used activation function in neural networks. So you have, four types of, commonly used activation functions. I told you one is the linear function, or, we will call it as the rectified linear unit ReLU. The sigmoid function, then the step function, then the hyperbolic tan. These are all the four types of activation function we use in neural networks. So activation function, as we discussed, it defines whether a given node should be activated or not based on the weighted sum. Now so to understand more clarity on the bias, weights, all these aspects, please watch the previous videos. These are all the fundamental concepts in neural network, and we will start with the step function. The first function we usually use here is the step function. See, I can show you the step function. It is I think now, yeah, this is a step function. See, the unit step function, or we also call it as the Heviside function, named after Oliver Heviside. So this function we call it as the 1 second. It is I can tell you it is unit. First we are going to discuss about the unit step function. So this is first we are going to discuss about the unit step function. Unit step function, this is unit step function. It is named after, we also call it as Heviside function. Heviside function, H-E-A-V-I, Heviside function. This is another name for this activation function, Heviside function. It is named after Oliver Heviside, another scientist. It is Oliver Heviside. So this is the first thing we are going to discuss, that is step function. That is, we call it as the unit step function or Heviside function, named after Oliver Heviside. See, if you see the the graph, if you want to see it, it looks like this is the graph. See, it's plotted in the red color. So the graph, the function, it is if we are plotting t and the function ft will be 0 when t is less than 0. So if t is less than 0 means it is -1, -2. At that time the function ft is 0. That means it's passing through the negative x-axis there. And when t is greater than 0, the function will give a sudden jump towards 1. Right, it is it give a sudden jump towards 1, that then it will give, after that it will be constant. So the red color represents the function, the unit step function. So it's written here, if ft it is equal to, for t less than 0, ft is 0. The function is in the negative x-axis. After that, if t is greater than 0, it will give a sudden jump towards 1. and the function will be, then after that it remains constant. So this is the unit step function. If you want to get a practical example for this, step function, it is, the variation of voltage when the switch is on. This is a practical example for the unit step function. When the switch is off, the voltage is 0. After that, when the switch is on, the voltage suddenly jump to maximum. That is the practical example of a step function. We can give the variation of voltage when the switch is on. See, the drawback here, it's for neural networks and all, we are not using this unit step function as the activation function. The reason is, the drawback here is the node can only have value 1 or 0 as output. See, for a particular node, when we are activated by using this activation function, the drawback here is the output value can be, this function is having only two values. One is the 0 value, and another one is the maximum value, that is 1. That is the drawback. In between, if some value, if we need it, it is not possible. That is the drawback of the step function. So this is all about step function. Now I will get into the linear function, that is ReLU. See, linear function you can understand like it is a it's a linear line. It is like so this is a linear function. See, this is not a ReLU, it is a simple linear function. It is, the equation of this line, we can write it as y is equal to mx plus b. In your, mathematics class, even in school mathematics, you learn it. The equation of a straight line, y is equal to mx plus b, where m is the slope of the line and b is the y-intercept. So this graph, this is the, this straight line, this is the linear function. If you can see it here, like this is the this is the linear function. But if you want about the rectified linear ReLU, rectified linear unit function, I can tell you it is like how it will be like. It is a rectified linear unit will be like it is almost same, but it would be, you have the y-axis, then you have the x-axis. This is x and this is y-axis. The rectified linear unit means for some time it will be like that. After that it would be a linear graph. So this is the ReLU function. Sometime it should be straight line. After that again it would be a straight, sometimes for the first part it is parallel to the x-axis. It's the value of the function is constant. After that it is proportional. It's having a linear relationship. See, in this area it's having a constant value. The function is having a constant value, but the value of x is changing, but the function f of x here, it is not changing here in this area. After that it is again varying. Both are linearly related, both are proportional. This is the ReLU function. This is the ReLU function, rectified linear unit. ReLU function, also known as how do you write it, is like this is the way you write it, ReLU. This we call it as rectified linear unit. This is ReLU function. So in the activation functions, we covered the step function, the linear function. So I already told you, in a neural network, the activation function defines whether the given node should be activated or not based on the weighted sum. So different types of activation functions I told. One is the step function, after that ReLU or linear function. Now I will talk about sigmoid function and hyperbolic tan. So next one is the sigmoid function, and it is the most commonly used function in neural networks. I can tell you it is the most commonly used function. The sigmoid function is the most commonly used activation function in neural networks. See, a sigmoid function, it is represented by, you can write it as, Sx, it is equal to, I will give you the equation for that sigmoid function. The sigmoid function will be, you can write it like this. See, this is the equation for sigmoid function. Sx is equal to 1 by 1 plus e raised to minus x. This is the equation. This is really important, very, very important. Sx is equal to 1 by 1 plus e raised to minus x. This you can write it as e raised to x. When you multiply both the numerator and denominator by e raised to x, you will get e raised to x by e raised to x plus 1. This is also, some people will represent it as like this. So how you got this? You multiplied e raised to x in the both the numerator and denominator. So this is the sigmoid mathematical explanation for the sigmoid function. Now I will come into the plot, the graph. You can get it for the sigmoid function. So here also I have written it is 1 by 1 plus e raised to minus x. In the x-axis, it's the graph is not getting into the negative y-axis. That's what one thing you can see. The graph is, the sigmoid function is completely in the positive y-axis. Sorry. And in the x-axis you can see 2 4 6 and minus 2 minus 4 minus 6 in the negative x-axis, and the y-axis you have 0.5 and 1, and the graph is steeper between you can see it in minus 2 and plus 2. In that region the graph is steeper. After that it's in the value in the y-axis, when it becomes equal to 1, it's it almost remains constant. So this is the plot of the sigmoid function you will get when you plot this graph. 1 by 1 plus e raised to minus x. When you plot this function, if you are if it is plotting between s of x and x, s of x means 1 by 1 plus e raised to minus x. This is the graph you will get. In the y-axis you will take s of x, and in the x-axis you will take x. See, s of x means 1 by 1 plus e raised to minus x. So it has many properties. This sigmoid function has many properties which makes it so popular, because I told you, in the neural network we are always using sigmoid function. The one advantage is it is a non-linear function, because it can have the output, it can give multiple values, multiple options. In the neural networks we can't predict what should be the output. We cannot go into a step function or a we cannot go, because it's having only predicted values. But here it varies between 0.5 to 1. It changes. Even it get into the in the negative range, it will again come down from 0.5. So it's a non-linear function, and the range values are the range, it is taken between 0 and 1. See, we have the values of the sigmoid function. It varies from 0 to 1. So the minimum value is 0. The minimum value of the sigmoid function, it is 0, and the maximum value of the sigmoid function is 1. So if you take the sigmoid function, minimum value, it is I can tell it as 0, and max it is 1. In between 0 and 1 you can get any value. In the case of a sigmoid function, that's what you can see it here. It varies from 0 to 1. And between if you see in the x-axis, between minus 2 to 2, if you see in the x-axis between minus 2 to 2, the function is very steep. That cause the function to tend to classify values either 1 or 0. In this region, see, between minus 2 to 2 on x-axis, this is a really very important point. Between minus 2 to 2 on the x-axis, if you see the function between minus 2 to 2 on the x-axis, the function is very steep. So that causes the function to tend to classify values either 1 or 0. Even this function can be used for classification. So that's another advantage. So because of these properties, it allows the nodes to take any value between 0 and 1. So the advantage in the neural networks, the any node can take, because of this properties, it allows the node, the sigmoid function allows the node to take any value between 0 and 1. That is the most important advantage of the sigmoid function. So this is all about sigmoid function. Now I am coming into the last one, that is the hyperbolic tan. So to understand about the hyperbolic tan, see, I will just tell some mathematics behind the hyperbolic tan. That is another thing. So hyperbolic tan, it is, you can understand some maths. See, these are all simple mathematics only. We are using it here. So the hyperbolic tan, you need to understand some of the formulas for hyperbolic tan. You may be familiar with. See, you are familiar with sine, cos, tan. Those are all the trigonometric functions. After that, you come up with the hyperbolic sine, hyperbolic cos. You have hyperbolic tan. You have, if you want to know the formulas for sine hx, hyperbolic tan, sine, we call it as the hyperbolic sine, we call it as sine hx. So sine hx, if you want sine hx, the formula for sine hx is e raised to x minus e raised to minus x divided by 2. This is the formula for sine hx. If you want cos hx, it is this is cos hx. It is e raised to x. It is, you learn it in your mathematics, e raised to x plus e raised to minus x by 2. So you try to learn these equations. These are all not complex equations, because it would help you in understanding the artificial intelligence and machine learning algorithms and the maths related to these artificial intelligence, machine learning, robotics, these technologies. So sine hx, it is known as hyperbolic sine. It is e raised to x minus e raised to minus x by 2. Here you need to understand this is, see, this is sine hx. And cos hx, it is e raised to x plus e raised to minus x by 2. This is cos hx. The basic, even in your high school classes, you are learning sine by cos is tan. In the same way, tan hx, when you divide sine hx with cos hx, you will get tan hx. So the tan hx will be, when you divide, you multiply with the reciprocal. So you will get tan hx as, so this is the simplest mathematics you can use. So you will get tan hx as, so you can write it here, tan hx is equal to, this is the formula. When you divide those fractions, you will get it as e raised to x minus e raised to minus x, the whole divided by e raised to x minus e raised to minus x divided by e raised to x plus e raised to minus x. This is known as the tan hx. This thing, some people will represent it as e raised to 2x minus 1 by e raised to 2x plus 1. So how you get that is, when you multiply e raised to x both in the numerator and denominator, if you are multiplying e raised to x both in the numerator and denominator, this becomes e raised to 2x and this becomes 1 by the law of exponents. So this, when you multiplying both numerator and denominator with e raised to x, you will get e raised to 2x minus 1 divided by e raised to 2x plus 1. This is the hyperbolic tan. So this is the function, this is the activation function we commonly used as, call it as hyperbolic tan. So the graph for the hyperbolic tan, I can show you. This is also most commonly used activation function in artificial intelligence, machine learning. So this graph, it looks like, so this is the graph. It's also interesting. See the tan hx and x. So it varies. Again, you can see it's like it's somewhat similar to sigmoid function, but it is sigmoid function. I told you, it varies from 0 to 1. It varies from its output values is between 0 and 1. But if you want a negative value, if your output wants to change from -1 to 1, hyperbolic tan is the best option. In sigmoid function, you will get any value as output between 0 and 1. But in a step function, you will get either 0 or 1. Right, you won't get any value in between 0 and 1 in a step function. The practical example I told you is the voltage, which is when the switch is on, it suddenly jumped to 1. But in the case of sigmoid function, you will get any value between 0 and 1. That's the advantage of sigmoid function. That is the commonly used activation function in our neural networks. But in the case of the this thing, hyperbolic tan, its value, if you have an application, it's output, the node should have the values between minus, or the output value must change from -1 to 1. Then tan hx, hyperbolic tan, is the best option. Its value varies between -1 and 1. So this is the hyperbolic tan. So we covered all the 4 activation functions here. Now, again back to, so next thing we need to discuss, see, in our if you see the topics under neural networks, these are all the topics I am planning to cover. So in the first video we covered the model architecture. In the second video we covered the mathematical interpretation of the model, and in this video we covered activation functions, and I am going to discuss about the bias node as well. So bias node, let us come to the bias node. So weight and bias, see, I already discussed in the previous videos as well. So the weight and bias is the 2 most important aspects in neural networks and in machine learning, artificial intelligence. See, weight and bias. Weight and bias. So the most simplest explanation, see, the basic explanation I can give you is, see, for example, if you take, this is the equation of a line, y is equal to mx plus c. You are familiar with this equation, and in this line, in this line, m is the slope and c is the y-intercept. These aspects you may be knowing it. Then I can tell you the simplest explanation for this is, here m is the weight and c is the bias. So in this way you can understand. And so I told you about the weight and bias. Now even using the bias node, see this weight. So I am talking about the what about weight? Normally it happens to the node, the weighted sum, what exactly it will do, all these aspects we discussed. See, using the bias node is usually critical for creating successful learning models in the case of neural networks. So in short, what we will do is, see, a bias value allows to shift the activation function to the left or right, and it helps getting better fit for the data. Very important. So I told you, see, a bias value allows to shift the activation function to left or right, and it helps getting a better fit for the model towards the data. So we will get a better fit model for the data. So what this bias function will do, it will shift the activation function to left or right. See, I can tell you here the bias, what's the role of bias here is, bias, well, it will shift the activation function left or right. Shift the activation function is denoted by the letter G or sigma. We discussed that. Shift the activation function left or right. This is bias. So what is the advantage when you are shifting towards left or right? What will happen? So we will get a better model. So it should be, it helps the model for a better fit towards the data. So it will, the bias value allows to shift the activation function to left or right, and it helps getting a better fit for the data. So this is the how we change the bias. Now when you even we already discussed, the bias we usually add. See, adding or subtraction. See, bias we usually add, because I told you in this equation y is equal to mx plus c, we are adding the bias. C is the bias. So this adding or subtraction, addition or subtraction, that's what towards the input x, it will shift the function left or right. But the multiplication, this is the weight, m is the weight. See, this multiplication, what it will do, it makes the function steeper. So that's also important. So that is the role of the weight. See, the weight, what it will do, so the weight makes the function steeper. This is the most important concept I am telling you. Please understand, weight makes the activation function, makes it steeper, makes the activation function steeper. So what is the advantage? When you make it steeper, you will get a better fit for the data. Your machine learning model will be doing a better fit for the data. So the weight makes it steeper. Weight means multiplying with the input, that is y is equal to mx, multiplying m into x, multiplying with the input. Your weight makes it steeper, and you can by trial and error, you can get a better fit for the data. Bias means addition. You are adding the value towards the input, so that shift the activation function left or right. So this is about the bias and the weight. Bias node, what is the importance of bias node, I clearly explained. If you want more clarity, I can tell you. See, for example, this is what you can see it here. This is the graph. This is the graphical explanation. I can tell you this is the line y is equal to mx plus c. This is the graphical explanation I am giving you. Y is equal to mx plus c. What is c here? This is c. What is m here? M is, so this line you extend here, then you will get this angle theta. The tan of this theta, tan theta is m. Tan of this theta, tan theta is m. Tan theta is m. Tan theta is equal to m. So when you change this theta, the tan theta will increase. When the theta is increased, the tan value is also increased. So you will what it is, the line, because when you change this theta, what will happen, the line becomes more and more steeper, right? When you change, this addition, see, this is the bias, this we call it as the bias, and this we call it as the weight. So by changing the weight and the bias, you can get a better fit line for the model, for the data. You can get by changing the weight and the bias, you can get a better fit model for the data. So by addition towards the input, that is the bias, you can shift of the function, the activation function, towards left and right, and by multiplying with the weight, you can make the activation function more steeper. So in this video, we have covered different, what is activation function for a neural network, different types of activation functions, and what is the bias node and how the weight works. All these aspects we covered. So in the coming videos, we will be discussing about the cos function. See, the first these four aspects we covered. So in the coming videos, we will be covering the cos function, For the neural network, then the forward propagation algorithm, back propagation algorithm, all these aspects will be covering in the coming videos. So thanks for watching.